Hello everyone, welcome back to part 2 of our MSSQL Database Administration crash course. This is your host Mohan. In our last video, we have covered the basics, what a database is, the different editions, and the daily life of a DBA. All the topics which we have covered are marked as green check marks in the slide. In today's video, we are diving deep into one of the most important topics, SQL Server installation and configuration. So we will go through how to plan your installation, how to install default and named instance, what are the important post installation configuration, and understanding SQL Server services and the startup parameters. And finally, some common interview questions that will help you confidently answer in DBA interviews. There is one bonus topic that is SQL Server versions and features. In our last video, we looked at the different versions of SQL Server, but we didn't dive into the details. Today, I'm going to explain the key features added in every version starting from SQL 2000. This video is a bit longer because these topics are very important. I'll explain not just what the features are, but why they matter so you can truly master them. These SQL Server evolution topics from TempDB auto configuration in 2016 to always encrypted ADR, Polybase, BDC comparisons, GraphDB, and modern features through 2025 are critical for senior DB interviews as they demonstrate deep understanding of Microsoft's architectural improvement across versions. Before we start, I want to share that making these videos takes a lot of work, sometimes a full day for just one video. Your likes, comments, and subscriptions are what keep me motivated. If this channel grows, I plan to expand into other areas like DevOps. So if you find this helpful, please subscribe and share it with others. With this, let's get started. SQL Server has a long history, starting all the way back in 1989 with SQL Server 1.0, which featured a simple 16-bit engine and very basic stored procedure. Over the next decade, we saw versions like 1.1, 4.2, 6.0, 6.5, leading up to the release of SQL Server 7.0 in 1998. I have listed one-line summary of the features for these early versions on the slide. You can quickly read through them for the context. While these versions are considered a legacy or stale by today's standard, it is still helpful to see where the technology began. Now let's move forward to the year 2000, where SQL Server really started to evolve into the powerful system we use today. SQL Server 2000 released on March 8, 2000. It was the first version to support 64-bit architectures and scale to handle terabyte-sized databases. Its extended support ended in April 9, 2013. What are the key features in SQL Server 2000? First is the analysis services. This replaced the old OLAP services. It allowed companies to analyze huge amounts of data and predict businesses' trend. You could turn raw sales numbers into smart insights without needing external software. Next is the reporting services or SSRS. SSRS introduced later in 2000 lifecycle. SSRS allowed you to build professional level reports directly from the server. You could schedule them to run automatically and email dashboards to your team. The next feature is Service Broker. So this feature added built-in messaging inside SQL Server. Applications could queue tasks reliably, like handling a customer order, without the app having to wait for the database to finish every single step. Next is the log shipping and enhanced replication. So log shipping was a simple automated disaster recovery tool. It backed up the transaction log on one server and restored in the other server. We call it a secondary server. If the main server died or failed, you could switch to the backup server quickly or to the secondary server. In the enhanced replication, so replication got much faster and smarter. It added merge replication improvements, allowing data to sync perfectly across multiple servers, even if they were sometimes offline, like a salesperson's laptop. In that scenario as well, this replication was able to catch up. Next is the basic XML support. For the first time, SQL Server became web friendly. You could write a query and have the results come out as XML, which was the standard language for the internet back then. The next is user defined functions or UDFs. UDF lets you write your own custom math or logic in T-SQL and reuse it everywhere, just like you would in a programming language like C++ or Java. Next is the indexed views. Usually, a view is just a saved query that runs every time you look at it. An indexed view actually stores the results on the disk. This made complex reports run 10 to 100 times faster because the math was already done. The last one is the DTS or data transformation services. You can say this DTS was the grandparent of SSIS. It gave you a drag and drop designer to move data from one place to another, cleaning and transforming it along the way. The next is SQL Server 2005. SQL Server 2005, released in November 7, 2005, brought revolutionary features like XML support and CLR integration that transformed database development. Its support ended in April 12, 2016. So below are the key features. First is the database mirror. By using database mirroring, we could do automatic failover to hot backup server, or we can say standby server, where we don't need a shared storage or shared disk. Standard edition businesses got the enterprise edition like high availability at normal prices. Next is the snapshot isolation. Before 2005, SQL Server primarily used locking to manage data integrity. This created a famous problem. Readers block writers and writers block readers. If someone was running a long report, no one could update the data. If someone was updating the data, no one could run a report. So snapshot isolation solved this by moving a row versioning model, also known as multi-version concurrency control or MVCC. In isolation level, we could read data without waiting for the writers. So now, two to three times more users could work simultaneously without blocking each other. Then comes the game changer, SQL Server Management Studio or SSMS. So SSMS replaced Enterprise Manager or Query Analyzer. This one app handled everything. We had Object Explorer, we have Query Editor. It was the best for the faster troubleshooting for everyone. Next, the CTE or Common Table Expression. By using CTE, recursive queries became simple by using with clause syntax. Hierarchy relationships like employee managers and complex joins can be written cleaner without the temp table using CTE. Next is the XML native storage. So now databases could store XML files directly. Next is the online indexing. With this feature, we could rebuild indexes without locking tables during business hours. As a result of this, large tables can be available during maintenance and eventually reducing the scheduled downtime. The next is data partitioning. By using this feature, we could split a big giant table across files automatically by day or by month or by years. So monthly sales data can be partitioned for the faster queries and easier archiving of old data. And the last one is the CLR integration. CLR means Common Language Runtime. So by using CLR, .NET developers could write stored procedures, functions, and triggers in C Sharp or VB.NET. Complex math or string operations also could run faster inside the database. Now moving to SQL Server 2008 and 2008 R2. So SQL Server 2008 was released in August 2008 and 2008 R2 was released in April 2010. So these versions introduced enterprise-grade security, performance, and management features. And the support of both ended in July 9th, 2019. So what are the key features which was introduced in SQL 2008? So first was the TDE or transparent data encryption. So TDE encrypts entire database and backup automatically without any app changes. So data stays secure on disk and it was the perfect for compliance. Next is a resource governor. So resource governor limits CPU and memory for specific users or apps to prevent resource consumptions from one app or one user. So one slow query can't crash your entire production system if we have the resource governor. Next is the file stream. Now we could store large files like documents or images on a file system in the form of blob or binary large object while keeping the metadata in the database itself. Next is the backup compression. Using backup compression, we could shrink backup files 50 to 60% automatically. So we can perform faster backups over networks, less storage, quicker restore in case of disasters. The next one is the change data captures. So CDC tracks every insert, update, and delete change automatically when we enable it. Now we talk about the SQL Server 2008 R2. So it has multi-server management. It means you can register multiple servers in SSMS. You can run queries, scripts across all at once. So if you go to your SSMS, you can see it and you can see it in the form of a registered server where you can create a group, and in the group you can register multiple SQL server. You can run one query in all the SQL server at once. By using Power Pivot for Excel feature, we can do in-memory analytics inside Excel. We can handle millions of rows, complex calculations very fast. So it has self-service BI without IT bottlenecks. Next is the Master Data Services or MDS. So it cleans duplicates, enforces enterprise-wide standards. Now comes SQL Server 2012. So SQL Server 2012 came out in March 2012 and completely changed high availability and analytics with always on and column store indexes. Microsoft stopped all security support on July 12, 2022. So everyone needs to upgrade now for safety. The first feature was the always on availability group. So it replaced mirroring with readable secondary replicas for automatic failover of multiple databases. One of its main features was to offload backups and reporting to secondaries without shared storage. We will discuss about it in details in our later sessions. The next one is the column store indexes. So column store indexes store data by columns instead of rows. Due to this feature, analytics queries run 10 to 100 times faster on the data warehouses. Next one is the contained databases. Contained databases store users and passwords inside the database itself. Contained databases store users and password inside the database itself. So no server level login needed. So moving the databases between servers becomes super easy with no headache of syncing the users. So it solved the problem of orphaned user while moving the databases between servers. Next is the file tables. So file tables is a feature introduced in SQL Server 2012 and also available in the later versions that extend the file stream storage capability. They allow you to store files and dictionaries or folders in a hierarchical structure directly within a SQL Server database while making them accessible as a regular Windows file share via assembly protocol. So consider a healthcare organization that handle vast amounts of unstructured data like scanned medical reports or x-rays or the consent forms. Storing these in separate file system leads to fragmented backups or weak security and difficult querying metadata. For example, if you want to find all the PDFs created after a certain date for a patient, it was very difficult. With this feature, it stores file in a file table with metadata, that is patient ID, date, and type. So these will be stored in the form of SQL table column. So user access files via Windows Explorer if he wants to edit it, while you can use the T-SQL for querying the data. For example, if you want to select all the medical records for certain period, you can do it by using the SQL queries. Next is the user-defined server roles. So user-defined server roles are a security feature that allow database administrator to create custom roles at the server level. Before 2012, we used to have fixed roles like sysadmins, DB creator, server admin, etc. So permissions under these roles are fixed and the user does not have any control over its permissions. Users could not modify the underlying permissions, right? So by using user defined roles, we have the granular control. User defined server roles help implement the principle or login of least privilege by modifying permissions to a specific needs. It reduces the security risk in multi user or enterprise environments. Next is the SQL Server 2016. SQL Server 2016 released in June 2015. It was built on previous releases with a strong emphasis on security, performance, cloud integration, and analytics. It introduced advanced capabilities for handling big data, machine learning, and hybrid cloud scenarios while enhancing tools like integration services and reporting services. Key themes included better data protection using always encrypted, querying unstructured data using JSON or Polybase, and in-memory optimizations. Note that SQL Server 2016 reached the end of mainstream support in July 2020 and extended support will end in July 2026. So the first feature was the query store. Query store acts as a flight recorder or black box for the query performance. It continuously captures and stores information about executed queries, their execution plans, runtime statistics, that is CPU time, duration, or I/O, and the wait types. This data is stored in the database tables within the user database itself, making it easy to query and analyze without external tools. Next is the temporal tables. Temporal tables or system version tables in SQL Server automatically track and store the history of the data changes in the table. They enable time-based querying of your data as it existed at the point in the past without requiring manual auditing code. So let's understand this. Suppose you have created a table with temporal support in SQL Server. Over the time, you have inserted multiple rows, you have modified some rows. For example, you have updated the salaries or status and deleted few other rows. To review these changes and understand the evolution of your data, you can query the table directly using the for system underscore time clause. This retrieves all historical versions, showing exactly what was updated, inserted, or deleted at specific points in time. It did not need any custom audit logs or triggers. The next is the JSON support. So JSON support in SQL Server 2016 refers to the native integration of JSON, that is JavaScript object notation, handling directly into the T-SQL language and query engine. It allows you to store, query, modify, and output JSON data without the need of custom code, CLR, or common language runtime assemblies or external tools. Next is the Polybase. Polybase is a data virtualization technology that allows your SQL Server instance to query data from external sources using standard T-SQL or T-SQL. Essentially, it acts as a bridge between the structured world of relational databases and the unstructured or semi-structured world of big data. So let's understand this with an example. Consider a giant e-com company like Amazon. Assume it has 1 million rows in order tables in SQL database. It also saved 10 billion rows in click stream logs in Hadoop, meaning which customer have viewed which page, how much time it is spent, what he bought. These details are stored in the click stream logs in Hadoop. Now our goal is to find the customers who bought more than 10K worth of items and also visited more than 50 pages. Before the poly-based support, to analyze the data together, you have to copy or move all the 10 billion rows, Hadoop rows to the SQL Server, which needed a super fast network and significant time. This means building complex ETL pipelines to physically move terabytes of data from Hadoop into SQL Server. This was slow, expensive, and the data was often stale by the time it arrived. Also, we need developers who have knowledge of SQL, Hadoop, Java, Python. Also, storing this massive amount of data, which is rarely used in SQL, was incredibly expensive. Think of a polybase as a window rather than a box. Instead of moving data into the SQL box, polybase opens a window that lets SQL Server look at the data where it currently lives. So how it does it? It first create an external data source. You tell SQL Server where the Hadoop cluster or Azure bucket is located. Then you create an external table. So you define a schema in SQL that maps to the files sitting in Hadoop. SQL Server does not import the data. It just creates a pointer. With Polybase, we can save on cost, resources, and time while dealing with data which is present in external sources like Hadoop. Next is the stretch database. Stretch database automatically move your old or rarely used cold data from on-premise SQL Server to cheap Azure cloud storage while keeping it fully queryable with normal SQL. Let's understand this with an example. Consider a company has 10 years of sales data, or it has a compliance that it must keep 7 to 10 years of transaction history. In such scenarios where only recent data, maybe 2025 data, is changing and the data before 2025 is cold or rarely changes. Now, storing this huge data, let's say 5 terabyte of data, is very expensive. It can cost around $50K in a year. It slows down your queries. Backup time also increased due to this size of data. With the help of Stretch database, we can keep recent data in SQL Server, which has size in few hundred GBs, and rest of the data or the cold data in Azure. So now if you want to run query or on recent data, it is fast and cheaper. If you want to query old data plus recent data, it will use smart join and queries that can run in few seconds. In our scenario, using Stretch database, we can save cost of local storage plus backup, and also can save time and get better query performance. A Stretch database can give you 99% cost saving. Please note that Microsoft retired Stretch database in July 2024 for SQL Server 16, 17, 19, and 22. It recommended create external table as select or CETS in SQL Server 2022 plus additions for archiving cold data to Azure storage. Next is the multiple TempDB data files. Before SQL Server 2016, SQL Server used to create one data file and one log file in TempDB database by default. So after the installation, you had to add TempDB files, resize them, and set autogrowth manually. So if you miss such settings, your TempDB is misconfigured, and if you move this in production, it will give you a performance issue. Starting SQL Server 2016, you can set the TempDB configuration during the installation only. It auto creates multiple TempDB files based on the number of CPU cores. Next is the always encrypted. Always encrypted keeps sensitive column data encrypted at all times. Even the DBA and sysadmin cannot see that. And it also keeps the sensitive column encrypted during the backups and network transit. Client apps encrypt, decrypt using keys stored outside SQL Server. Let's understand with an example. You are a DBA and you have the direct access of the databases and tables of sensitive information like users, accounts, balance, transaction history, etc. But compliance says the sensitive data needs to be encrypted. With this always encrypted feature, client app encrypts sensitive data like account balance or transaction history. Then SQL stored this encrypted data, and DBA can see some random alphanumerical text and they can't understand. And then when this data being queried, application decrypts the data with the external keys. Moving next to the SQL Server 2017. SQL Server 2017, released in October 2017, brought Linux support and intelligent query processing as a game changers. So its extended support will end in 12th October 2027. So let's talk about the key features. So first is Linux and Docker support. SQL Server runs natively on Red Hat, Ubuntu, SUSE, Linux, and Docker containers. Same T-SQL engine across Windows or Linux hybrid deployments were simplified using the SQL Server 2017. Automatic database tuning in 2017 is like having a smart DB assistant that automatically fixes slow queries. Consider you have written a select queries. On day one, it executed in half seconds. Over the time, the query may take 30 seconds due to new bad parameter sniffing plan. If you enable automatic performance tuning, SQL Server automatically switches back to last good plan. For this feature to work, you need to enable the query store, which trace query performance history. Next is the graphs database support. In traditional SQL Server, finding friends of friend or employee manager relationship in table requires complex self joins and CTEs. But with the graph solutions, we can replace 20 line self joins with one line match for connected data. Moving further, we have SQL Server 2019. SQL Server 2019, released in November 2019, brought big data clusters and intelligent query processing as a major leap forward. Extended support will end in January 8, 2030. Let's talk about the key features. First is the big data clusters. So, big data cluster in SQL 2019 combine SQL Server plus Spark plus Hadoop into one Kubernetes cluster. It can query petabytes of mixed data with normal T-SQL. Consider a company has the user data where SQL Server has the customer data of around 10 GB. It has web log streams, as I said earlier. I mean, what about what the users are doing, what pages they are accessing? Those information will be stored in Hadoop, and we have user profiles which we have saved in the MongoDB. So with big data clusters, you can query all the data with one T-SQL statements. Don't confuse it with the Polybase feature. In Polybase, SQL queries external data through Hadoop or S3 from single SQL server. It has a simple setup. With the big data clusters, you can do petabyte of data analytics using Kubernetes cluster with multiple sources. It has a very complex setup. Next is the accelerated database recovery or ADR. It is a complete redesign of the SQL Server recovery engine. Its primary goal is to make the database recovery instant and constant, regardless of how many long running transactions were active when the system crashed. In the traditional recovery model, we also call it ARIES. It is invented in 1990. So ARIES, the full form of ARIES is Algorithm for Recovery and Isolation Exploiting Semantics. If you have the transaction that has been running for 5 hours and server crashes, then SQL Server must go through these three phases. One is the analysis phase, redo phase, and the undo phase. In the analysis phase, it will scan the log to identify the active transactions. In the redo phase, it will replay every operation in the log since the last checkpoint to bring the database to the state it was in at the crash. And next is the undo phase. So here it will physically scan the log backwards to undo that 5 hour transaction. The database remains offline or restricted until this finishes, which could take around 5 hours. With the ADR or accelerated database recovery, the undo phase from a slow sequential log scan into a fast version based switch. It has four phases. You can read more about it if you are interested. Next is the memory optimized TempDB metadata. So memory optimized TempDB metadata is a performance feature that aims to eliminate one of the most common bottlenecks in high concurrency environment, that is a metadata contention. In a standard SQL Server setup, whenever you create a temporary table using create table statement, SQL Server has to record that table's existence in the system catalog that is located inside the TempDB. On a server with hundreds or thousands of concurrent users creating and dropping these temp tables every second, these system tables became a massive bottleneck. Why? Because it uses latches. Every time a system table is updated, SQL Server SQL Server places a latch or a lightweight lock on the underlying data pages. It creates contention. Hundreds of threads end up waiting for the same latch to be released. You often can see page latch underscore ex or page latch underscore sh wait types in your performance logs, specifically on TempDB. So by using in-memory or OLTP, or we also call it hackathon technology, SQL Server moves those heavy-duty system catalog tables from traditional disk-based pages into the memory-optimized latch-free tables. So memory-optimized tables do not use latches. They use an optimistic multi-version concurrency control or MVCC mechanism. This means threads no longer queue up to update metadata. They can all proceed simultaneously. Since TempDB is recreated every time SQL Server restarts anyway, these memory optimized metadata tables are configured as non-durable. This removes the overhead of logging metadata changes to the transaction log, making object creation even faster. Creation and deletion of temporary objects became nearly instantaneous even under extreme load. Next is the intelligent query processing or IQP. IQP is a suite of features in SQL Server designed to automatically improve the performance of your queries without requiring you to rewrite SQL code. The core philosophy of IQP is learn and adapt. In traditional SQL processing, the engine makes a best guess before a query runs and sticks to that plan. With IQP, SQL Server monitors the query when it runs or after it finishes and uses that real world feedback to adjust its strategy for the next time. Then comes the always encrypted with secure enclaves. It is introduced in SQL Server 2019 is the next generation of SQL Server's client-side encryption technology. While the original version 2016 was revolutionary for keeping data encrypted even from DBAs, it was very restrictive. You could not search for the ranges or you cannot use the like or on the encrypted data. So secure enclaves solve this by creating a black box of trusted memory where SQL Server can safely perform calculations on the sensitive data. Next is the UTF-8 support. It allows the database engine to store Unicode data using the varchar and the char data types. Previously, if you wanted to store multilingual data like Japanese or Arabic in SQL Server, you were forced to use nvarchar or nchar, which use UTF-16 encoding. UTF-8 support bridges the gap between SQL Server and the rest of the web, where UTF-8 is the dominant standard. Next is the SQL Server 2022. It is released in November 2022, introduced ledger tables for tamper-proof data and Azure Synapse Link for real-time analytics. The extended support will end in January 11, 2033. So what are the features which was introduced in SQL Server 2022? So first is the cloud connected features, or we can say the Azure integration. So here we have Azure SQL Managed Instance Link. By using Azure SQL Managed Instance Link, we can link our on-premise SQL Server to an Azure SQL Managed Instance. It's a game changer for disaster recovery. You can failover your local database to the cloud and back with minimal downtime. The next feature under this Azure integration is Azure Synapse Link. So this Azure Synapse Link enables near real-time analytics. It automatically feeds data from your SQL Server into Azure Synapse without you having to build complex ETL pipelines like SSIS. New feature of SQL Server Ledger is related to security. This is one of the biggest additions. Let's understand it. So in traditional system, even if you have auditing enabled, a high level admin could potentially delete audit logs. But in case of SQL Server Ledger, it creates an immutable history of all changes. Immutable means that once the data is written, it cannot be changed or deleted. So it links every change to the previous one. If a single bit is altered outside of SQL commands, the verification process will fail, making your data tamper evident. Next is high availability and scalability. 2022 introduced contained availability groups. So traditionally, logins, jobs, and linked server were stored in the master or the MSDB databases, making failovers very tricky. Now, these objects can be contained within the availability group itself, so they automatically follow the database to the new server. Next is T-SQL and storage enhancement. In SQL 2022, we have S3 compatible object storage. You can now back up your database directly to S3 compatible storage like AWS S3 using a URL or use Polybase to query files sitting in an S3 bucket. The last one in the list is SQL Server 2025. So SQL Server 2025, generally available as of November 18, 2025, is the most significant release in a decade, transforming the database from a storage engine into an AI-ready data platform. The primary theme of this release is AI and cloud agility, focusing on built-in vector support, seamless integration with Microsoft Fiber, and major developer productivity boost. So let's understand its features. First is the vector search and AI embeddings. So we have native vector data type in 2025. You no longer need to store embeddings as nvarchar or blobs. The new vector type stores embeddings significantly as single precision floating point values. If you are thinking what is embedding, so embedding is a way of turning human information like sentence, photo, or a song into a long list of numbers that a computer can understand. We also have disk ANN indexing. So it uses the disk approximate nearest neighbor or disk ANN algorithm for high performance vector similarity searches, making it a competitive vector database. And we also have external model management. So you can now register and call external AI models like Azure OpenAI, ChatGPT, or local Olama instances directly using the T-SQL commands via sp underscore invoke underscore external underscore rest endpoints. Next is the optimized locking. So this feature previously was available with Azure SQL is now available in the on-prem. It uses TID or transaction ID locking to virtually eliminate lock escalation and blocking, allowing millions of row-level locks without exhausting memory. You get around 30 to 50% better concurrency for high transaction OLTP workloads. Next is the temp DB resource governance. You can now set percent-based limits on temp TB usage to prevent a single runaway query from crashing the entire server. Next is the JSON column support. The new binary JSON type supports document up to 2 GB with much faster parsing and specific JSON indexes to speed up the queries. It speeds JSON queries by 10 times. It is the change event streaming. For the first time, SQL Server can stream row level changes like inserts, updates, and deletes directly out of the database engine to the external targets like Azure Event Hubs in near real time without the need of complex ETL tools or manual polling. If you have used change data capture before, change event streaming might sound similar, but it solves several major issues that CDC created. In the CDC, it writes changes to the shadow tables inside your database and it takes the space. But in the CES or change event streaming, it takes zero local storage. Changes go straight from the log to the stream. In the CDC, we have high IO overhead because it writes every change twice, one in the log, one in the table. But in case of CES, it has ultra low overhead. It only reads the log, it does not write extra data. And CDC is a pull based model where you must query the CDC tables, but in CES, it is push based. It sends data to you. Now, as we understood what are the features included in different versions of SQL Server, let's move to the next topic, that is planning SQL Server installation. So what are the key considerations you should keep in mind when planning a SQL Server installation? Whether you are setting up your first SQL Server or preparing an environment for a large enterprise, these 6 points will help you get it right from the start. First is the identify your workload type. Before you even start the installation, ask yourself, what kind of workload will this SQL Server handle? Is it OLTP, meaning lots of small transactions like insert, update, and delete? Or will it be an OLAP that will be more focused on reporting and data analysis? Or maybe a hybrid workload that does a bit of both? Knowing this helps you plan your storage, memory, and CPU allocation properly. Remember, different workloads have completely different performance and resource need. Next is the align with purpose or choosing the environment type. So we need to consider or we need to identify where and why you are installing SQL Server. Is it for production, testing, training, or for development? Each environment needs a different configuration level. For example, in production, you will focus on security, high availability, and backup strategies. But in the development, performance may not be as critical. But here you will choose or you will look for the flexibility and quick restore that will matter most. Clearly defining the environment type avoids over provisioning and unnecessary cost. The next is addition selection based on the workload. SQL Server comes in several editions like Express Edition, Standard Edition, Enterprise, and Developer Edition. So choosing the one that fits your workload and budget will be optimal for you. Express Edition is free but limited, so it is good for small apps or for learning. Standard Edition meets most business needs with core features. Enterprise gives you full power. It provides you high availability, performance tuning, and advanced analytics. Developer Edition is great for labs or personal environments because it gives complete feature but not licensed for the production. So we cannot use this Developer Edition in your production environment. So we need to pick very carefully. Your edition affects the capabilities, cost, and the performance. Next is the hardware and sizing consideration. Now you need to plan your hardware. So think of CPU, memory or RAM, and storage like SSD or HDD, and the network bandwidth. You should base your sizing on the expected workload. For example, OLTP environments need fast I/O and lots of memory for caching, but OLAP systems benefits from more CPU cores for query processing. Also, always separate data, log, and backup drives. It improves performance and recovery options. Next is feature selection during installation. When running the SQL Server installer, you will see several components, database engine, SSIS, SSAS, or more. Only install what you actually need. Unnecessary feature increase your attack surface and resource usage. For example, a transactional database server might need only the database engine. A reporting server, on the other hand, will need SSRS or Power BI report server. So always remember, less is more. Keep it lean and secure. The last consideration will be the post installation configuration and best practices. After installation, it's time for configuration and tuning. A few must do steps will be setting up your backups, monitoring, and alerts. You need to configure the TempDB with multiple data files for performance if you have not set already during the installation. Next is adjusting your server memory setting, max server memory or min server memory. You need to leave enough memory for OS or other applications. Then you need to enable the OLE automation or CLR only if required, or you need to apply the latest service packs or CU. And don't forget to secure logins and disable the default SA account if possible. These post-install tasks make sure your SQL Server is stable, secure, and optimized for real-world workloads. So if you conclude the points, just to recap, you need to identify your workload, you need to align with the environment's purpose, you need to choose the right edition, you need to plan hardware properly, you need to install only the needed features and tune it post-installation. Follow these 6 steps and your SQL Server setup will be strong, efficient, and future-ready. Now, as we have seen the key consideration for planning SQL Server installation, next we will install SQL Server in our system. For today's video, we are going to install SQL Server 2019 Developer Edition. So how you can download this? First, you can go to the Google and you can write download SQL Server 2019 Developer Edition. So the easy way is to go through this mssqltips.com, and if you click here, it will route to the website, and from here you can click on download SQL Server 2019 Developer Edition, and this will be downloaded wherever you want to download it. So I have already downloaded SQL Server 2019. So we are going to install that. So this is the file which we have downloaded. I will click here and I will say run as administrator. It will give you this window. I can click on yes. And after that, it will open a new window. So here you have 3 different options. Is basic, second is custom, and third one is the download media. So in the basic, if you select the basic option, it will install a default SQL Server database engine, and it will mostly do automatic settings, and it will ask very minimal questions. So if you are using it for the like lab installation, then you can choose this, but you cannot fine tune things like instance name or features or data directories or service account during the installation. So we will not use this today. Second one is the custom option. So custom option is basically it downloads the setup files and then launches the full SQL Server installation when you get all the normal pages like feature selection, instance configuration, collation, service account, etc. So we will be using this today so that we will have more control over the features which we want to install. Third option is the download media. So it will only download the full installation media or ISO file. It does not start or complete the installation. So for demo purpose, I will be using this custom option. So it will ask where you want to download this SQL Server media. So you can change this location and you can go and click install. So it is saying download is successful, and once it is done, it will open another window by default. And in this window, you can choose different options. Here you can click on hardware and software requirements, and it will route you to another website where you can check all the prerequisite hardware or software requirement for downloading or installing SQL Server 2012. You can click on 19. So whatever version you are installing, you can check the requirements from here. Other one is a security documentation, online release notes. So if you want to see what are those options, you can click on them and it will open another website where you can see information about each and everything. So when we are installing, we will go to the installation page here, and once you click on installation, it will give you different options, and for each options you will see the detail here. If you want to install new standalone SQL Server, or if you want to add features to your existing installation, you can choose first option. So if you want to install SQL Server reporting services, you can click here. If you want to install SSMS, you can click on this. So there are different options. So if you have a failover cluster, you can choose this option. If you want to add a node in existing SQL Server cluster, you can choose this option, but as we don't have the cluster, those options are disabled. And if you want to upgrade from previous version, for example, if you want to upgrade from 17 to 19 or 16 to 19, you can choose these options. And if you want to use new machine learning server, if you want to install a machine learning server, you can click here. But for our example, we are only going to install the standalone SQL Server. So we will click on new SQL Server standalone installation or add features to an existing installation. And once you click here, it will open another window. So we can click on next here, and here it will be checking for the updates. So there are no updates for SQL Server found online. I will click on next, and here it will scan for the product updates. It will download the setup files, extract setup files, and install setup file. So the previous step may take time, but as I have already installed SQL Server in my system, so it did not take much time. So here we have only one warning, that is for Windows Firewall. You can read the warning, but it is a warning, so you can ignore it, and it has passed all the checks. I will go and click next here, and here you see there are different options. One is perform a new installation of SQL Server 2019 or add features to an existing instance. So if you already have an instance, in my case, I have already installed the default instance which I have installed. So if you want to add features, you can click on this option and you click on next. But for new installation, you need to click on perform a new installation of SQL Server 2019. I will click next here. And here you can specify a free edition. So if you want to install developer, evaluation, or express edition, you can select it. And if you are using the standard edition or enterprise edition, you need the product key. So you can select here and you can enter the product key. But here we are using the free edition and we are going to install SQL Developer Edition. So I will click developer and I will click on next. Here I can accept it, click on next. And here comes the most important window, that is the feature selection. As a DBA, you often have limited choices and are told exactly which features to select during the installation. However, I have found that many DBAs don't actually know what these specific features do or how they help in the real world. So I'm going to break down each option and with clear examples so you can truly master them. So please stick with me until the end to see how it all works. So in SQL Server installation, the first one is the database engine services. So database engine services is the single most important component. It is the core service that actually stores, processes, and secures your data. Second is the SQL Server replication. So replication is a data distribution feature, and we use it for offloading reads or distributing data to other servers. It copies and synchronizes data and sometimes schema as well from one database that we call it as a publisher to the one or more databases we call them as subscribers. Second is the machine learning services and language extensions. We have options to install R, Python, and Java. So this machine learning services and language extension, it will enable running those Python, R, and Java scripts directly inside a SQL Server instance from T-SQL. And we also have the similar thing here in the shared feature, that is the machine learning server standalone with R and Python. So this machine learning server, it installs a separate R or Python runtime for use outside the SQL Server. So it is a shared feature, means it is independent of any SQL install, right? So here, if you want to use these machine learning features, you can install this one. And if you want to independently install machine learning server, you can click here. The next is the full text and semantic extractions for search. So full text enables efficient word or phrase searches across large text columns like documents, articles, or descriptions, while semantic search adds intelligent similarity ranking based on meaning, not just keywords. So if you have a database which has the e-com, for example, if you have an e-commerce website or e-com data, you want to search for a laptop or for a mouse, then full text search will give you all the related items, because in the e-com the data related to mouse or laptop is just not set as laptop or mouse. It can be a wireless mouse, it can be wired mouse, or can be Lenovo laptop or HP laptop. So by using the full text search, we can get all the related items which we are searching for. The next is the DQS. So DQS is a data quality services. In SQL Server, it is a data cleansing and deduplication engine that uses our knowledge base to correct, standardize, and match your data before it goes into the reporting or our data warehouse. So we will understand with example. So you can see here that you have a customer table and it is coming from multiple system and the data is very messy. So here you can see the India, we can write India in multiple ways, right? We can write like first capital letter, and then all other small letters, or maybe we can write it as all capital letter, or all the it can be a mix of both. Or maybe if you have an address field, then sometimes the pin number or pin code is missing in the address, or maybe you have a duplicate customer where the slightly, I mean, where the spelling difference is very slight. So in this case, what you can do, you can create a DQS knowledge base for domains like country, state, name, or pin. Then you can train this, and you can train it with the correct values and synonyms. Then you can run a DQS cleansing project, and after that, all the data will be standardized. Right, so it will correct the spelling of India as per the standard you want. It will fill or correct the pin code based on the city or state, whatever rules you have set. We also see here data quality client, right? So data quality client option in this setup, it will just install that it will install the GUI client application, and it is not bound to, one instance, and it can connect to any configured DQS server. So all the features which are listed here, those are independent, those are not instance specific. Okay, next is the Polybase query service for external data. This we have already seen in our SQL Server versions and their features, but still I will just give you a one-liner about that. So Polybase quality service for external data enables SQL Server to query external data sources like Hadoop, Azure Blob, or S3, and you can use it using your T-SQL. So it will treat all those big data tables as a native SQL tables. Next is the analysis services. So SQL Server Analysis Services, or SSAS, is an OLAP and data mining engine that creates multi-dimensional cubes or tabular models for fast analytics and the interactive reportings. Next comes the we have we have covered this machine learning, TQC. Next is the clients tool connectivity. So this clients tool connectivity in SQL Server shared, it is a shared feature and it installs ODBC drivers, OLEDP providers, SQL native clients, or TCP/IP socket, name pipe, shared memory protocols, so that you can connect your apps to SQL Server smoothly. Next is the integration services, and in the integration service we have scale out master and the scale out worker. So in SSI, so in SSIS, scale out is a feature that allows you to distribute the execution of packages across multiple computers. This is particularly useful for high volume ETL workload that would otherwise overwhelm a single server. So the architecture relies on two distinct roles, that is scale out master and the scale out worker. So let's understand this with an example. Imagine you have a retail company that needs to process sales data from 500 different stores every night. So if you don't have the scale out option, you need one powerful server that will try to run all the 500 packages. And if these data grow, the server may be running out of the memory and the CPU and the job fails. If this report is very critical, you will have the nightmare. With a scale out option, you may have server 1 that is treating as a master, and then you have server B, C, or D. Those are working as scale out worker. So what will happen? The master server or the server A will send maybe 10 packages to server B, 10 to C, and 10 to D. As soon as one worker will finish their work, then it will send another 10 packages. So by spreading the load across three machines, the total processing time is cut by nearly two-thirds. So this is all about the integration services and scale out master and the scale out worker. And next is the client tools backward compatibility. In the context of SQL Server installation, client tools backward compatibility is a feature that installs the necessary library and legacy components to allow newer versions of SQL Server to interact with the older versions of databases or packages or application. So for example, if your company wants to upgrade from 2012 to 2019, but it want to keep their old ERP software and where they have hard coded the connection string, so in such cases, if you don't have the backward compatibility, those ERP will fail with the error provider not registered or cannot generate SSPI context error during the login. But if you have the client tool backward compatibility installed, it authenticates via Windows authentication or Kerberos authentication, and it will query smoothly. So if you are sometimes if you are getting the provider not found error in old custom apps, then you can install it. It is being removed from SQL 2022 installer. Next is the Clients Tool SDK. So Client Tools SDK installs .NET assemblies and APIs like Microsoft SQL Server DLLs for programmatic access to SQL Server features from custom C# or VB.NET applications. Install Server Management Objects SMO and SSIS APIs. So you can also skip this for the basic install. It is only needed for the custom monitoring tools or SSIS orchestration purposes. It is needed for the custom monitoring tools. This feature is also removed from SQL 2022 installer. The next is the distributed replay. So what is distributed replay? In SQL Server, distributed replay is used to simulate real production workload on a test SQL Server. So it will help you to test the performance. You can validate the upgrades. You can find the bottleneck under realistic load. So consider a bank who is using SQL Server database and it is running in SQL 2016 in production and they want to migrate from 16 to 2019. The main purpose of upgrading is they want their queries to run correctly. They want the better performance under the real workload. In such cases, the process will be first they will capture the workload from the real production server in the peak hours. They will take a trace from those production during the peak hours, and then they will set up the test environment. So they will install SQL Server 2019 on target server. Then they will install one distributed replay controller, and they can have multiple distributed replay clients. So they will replay the workload they have received from the production. So the controller will read the trace, and this will distribute the work among different clients, and it will synchronize the timing. So client will execute the queries concurrently, and they will generate real production like load. Once it is done, we will compare performance before and after upgrade, and we will identify the slow queries or blocking issues. So this distributed replay controller or distributed replay client, they will use for testing SQL upgrades or maybe hardware changes or index rebuilds with production like load before cutover. So it is a enterprise edition feature and it is deprecated in SQL 2022. Next is the SQL Client Connectivity SDK. So SQL Client and Connectivity SDK is a set of client server drivers, libraries, and tools that allow applications and users to connect to SQL Server. In simple words, we can say it enables communication between an application and SQL Server. Next is the Master Data Services, or we call it as MDS. So let's understand this MDS or master data services with the example. So imagine a large family where everyone has their own contact list on their phones. Here the problem is, for example, a relative of them or a common friend of them changes his or her phone number. Then only half of the family members update their list and other half keeps calling on the old number. So the solution can be a family or this family can create a master address book on a shared website. Everyone agrees that the website is the only official source, and if that relative changes his or her phone number, it is updated once on the website and everyone's phone subscribes to that list. With this they will all have the contact updated in their phone, right? So if we talk about our real world example, here we have a company that sells the a laptop, and here the laptop name is different. So in the sales system the laptop name is written as ProBook 450 generation 8, and here in the warehouse system the name of the laptop is HP PB 450, and in the website it is selling as HP ProBook 15-inch. So those three names are different. So without the MDS, if the CEO asks that how many ProBooks did we sell, then the report fails because the names are different in each system. With the MDS, all three systems feed their data into a MDS hub. And our data steward or a person responsible for the data quality uses the MDS Excel add-in to map all three names to one master name. And the master name will be HP ProBook 15-inch, or it can be ProBook 450 G8, right? Then this MDS creates a subscription view. We can think subscription view as a SQL view, and then the reporting tool like Power BI pulls the data from that particular view, and it will ensure that all sales are correctly grouped under the one master name. So this is the importance of the MDS. And so as we are using this for demo, we will use this database engine services only. And if you want to know more details about that, you can either check in the Google or you can click on here and you can get the description of that particular feature. So you can see from here as well what that particular feature will do. Here we'll only select this database engine services. The instance root directory is the directory where your SQL server will install. And also here you can see the prerequisites for the selected feature. You can also check the prerequisites for the selected feature. Here we can see it is already installed and the disk space requirement is also mentioned and that is getting fulfilled here. I will click next here. And here you can see two options. One is the default instance and one is the named instance. If you are installing the instance for the first time in your Windows box, you will select this default instance and the name of the instance, and the name of the instance will come by default. You can change it. And if you have already installed SQL Server, for example, in our case, I have already installed two SQL Server. One is 2019 and one is 2025 in my system. So those will be showing here. So here I will go with the named instance and I will give the name as demo. So the name of the demo will change in the instance ID. Then I will click on next. Here you will see the name of the SQL Server Agent Service and SQL Server Database Engine Service and SQL Server Browser Service. Here you can see multiple if you have selected multiple features. And here the account name will be listed. Here it is coming by default, and you can, if you want the service account, you can choose from here. You can browse and you can check it from the Active Directory, right? And that startup type is manual, automatic, and disabled. So I will keep it as automatic. So if this startup type is automatic, it means whenever the Windows box is restarting, after restart these services will be restarted automatically. If you keep it as manual, then you need to go and manually start the service after every restart. So in production system, mostly where cluster is not there, we keep it as automatic only. Okay, so we'll keep this browser service as disabled. Next is the collation. So collation here, it is Latin one general CIAS. Collation in SQL Server refers how text or string data is stored, compared, and sorted. For example, in this default Latin one general CIAS, here Latin one general, it does not mean any language like Latin language. It means a Latin based character sets like alphabet A to Z, small letter, or alphabet A to Z capital letter. So it refers to the language and the sorting rules. Okay, and here I can change the name of the collation. From here you can select multiple collations from here, and you can say case sensitive or case insensitive. So here if we have selected case insensitive, it means all the three, like these three, India with first capital letter and another small letter, and this, all three will be treated as equal. And if you have selected case sensitive, then all of them will be treated as different collation, different string. Similarly with the accent sensitive and accent insensitive. So if you have put the accent insensitive, it means those two. You can see a little bit mark above E. In some language we keep this kind of mark. I'm not sure what this is called, but here both of them will be treated both of them will be treated as equal if we are selecting the accent insensitive, and if you are selecting the accent sensitive or AS, then both of them will be treated as different. So this is the language, this is the meaning of CI or AS. And one more important thing, whenever you are selecting the database collation, please confirm with your team or the requester which collation it wants to install. Otherwise, after installing SQL Server, it will be a long and complex process to change the collation name. I will click on next. Here you will see Windows authentication mode and mixed authentication mode. So Windows authentication mode, meaning only Windows user accounts or Windows groups are allowed to connect to SQL Server. So SQL Server trust Windows to authenticate the user. And then we have a mixed mode. So in the mixed mode, it allows Windows authentication mode, plus it will also allow user who has the password and the username. And then we have a SA or system administrator password. So this SA password is a member of server admin or sysadmin role. It will give you all the permission in SQL Server. So if you are keeping mixed mode, you need to enable it, or in the installation you need to give any password here. And there we have add current user or add different users. So in our SQL environment or in the production environment, most of the time we have different Windows groups or accounts. Those should have the admin permission, so you can do it from here itself. You can search those accounts in the directory and you can add it here, or you can add the current user. So the user which is installing, or the login name where you have used to which you have used to log into the Windows box, this will come it as a current user. So it is very important, in case if you are using the Windows authentication, it is important that you should use some users here, or you should add the current user, because sometimes after the installation, if you want to do some kind of troubleshooting, you will not be allowed to log in the SQL Server if there is some issue. So it is better that always you add the current user or add some user here. Here I will be using the mixed mode authentication. I will next go to the data directories. So here you can see this data root directory that is in the C program files, Microsoft SQL Server. So here, so this data root directory is the parent folder for all the data related files for a specific instance of SQL Server. And this system database directory, it will be grayed out and it will create a child folder inside the same location as data root directory. And here you will see all the system files, system database files, or system databases will be present here. Next is the user database directory. So in this you can click and you can change this user database directory. So as per environment, you may have different drives like F drive, K drive, L drive, whatever the standard in your environment. You can set the database directory here. So next time whenever you are creating any database, all the data files will go and store in that particular location. And similarly, we can we can define the database log files as well. You can again select any folder where it should go, and it will create the log files of the user database. And then we have the backup directory where we can take the backups. Next is the TempDB. So in earlier versions, this TempDB we need to set manually, but later versions we have this option to set from here itself, and the number of files it automatically selected as per the core CPU core. So it should be equal to the CPU cores. In my system, it has 4 CPU. That is why it is only selecting the 4 files. However, you can add more files or you can delete more files as per your requirement, but this is the recommended practice to keep the number of files as the CPU cores. Here you can set initial size as per your same auto growth you can set as per the standard, and similarly you can set the tempdb log files, and here you can set the directory of the tempdb. From here you can remove the files from here, and if you want different location you can add and select that particular folder. So in normal SQL Server production environment, you will always see the TempDB in different drives, because sometimes due to some bad queries, you can this TempDB can grow indefinitely and it can consume all the space. So that is, it is better or it is recommended practice to keep the TempDB in different directory. Then this is the max stop setting. So here the max stop stands for the maximum degree of parallelism, and it controls how many CPU cores or threads SQL Server can use to execute a single query in parallel. So I will keep it as default. Then we have a memory. So default is min memory as 0 and max memory as the whole memory in the system. But we can click on recommended. So it automatically calculates. So I have 12 GB of memory in my laptop. So it has given 9 GB in the 9 GB to the SQL Server. So, but you can change it as per your requirement. So normally, if you in ideal case, if you have only one instance in that particular Windows box, we keep max memory as 70 to 80% of the total memory, and we leave 20% memory for the other applications which are running, or the non-SQL application in that particular box. So next is the file stream. So file stream is a SQL Server feature that allows you to store large unstructured data like files in the Windows file system while still managing it through the SQL Server, right? But here we are not using file stream, so I will not enable it. And here I am getting something to continue. You must accept the recommended memory configuration for the SQL Server database engine. Click here to accept. Okay, let me click here. Let's see what it says if I click on next. Yeah. So in this page, you can validate and you can verify what are the features you have selected, what it is installing, where it is installing, what are the directories, TempDB memory setting, whatever you have set, it will show here. You can review it, and once you can review, you can install it. So this is the configuration.ini file, and this is the location. So it will have all the information about the instance, whatever features you have selected, whatever options you have selected, everything will be presented here. So in case if you want to install 50 SQL Server instances in different servers, then you can automate that process using the config.ini file. Here it will have all the configurations set. So here I will click on install, and it may take 10 to 15 minutes to install. If you have no error, if you have any error, it will display the error and you can work accordingly. So I will just pause my recording and I'll come back once the SQL Server is installed. Here we can see the SQL instance is installed. I will click on close, and I will go here in the SQL Server Management Studio. So this is one of the query. I will keep it in the description. So you can, by running this query, you can check whether the instance is default one or the named one. So here I have the multiple instances. I can click on local, and you can see, as I said, I already installed 2 instances. One was the default one and second one is the 2025, but this is the one which we are looking for here. And I will click on next. I will click on connect, and it is giving me error that we should this is the SSL provider. The certificate chain was issued by an authority that is not trusted. Simply I can click on trust this certificate, and I will click on next. So here I can see, let me remove those instances here, and I will right click, and here we can see we have this demo instance which is created, and here we can clearly see that is a named instance, and the name of the instance is demo. Here we can see we have system databases, master, model, MSDB, tempdb. I can run sp underscore help db here. So here we can see we have four system databases. If you want to see the detail of this master database, I can simply run this query and you will see everything about the instance here, everything about the master database. So this is all the default one which we have seen during the installation, right? And temporary also we can see what are the properties here. We can see the files. It has four files as we have seen during the installation. This is what we have set as per the installation, and this is the location. So everything is set and perfectly fine. So this is how you install the SQL Server instance in a Windows box. So now let's see the post install configuration in SQL Server. We can click on the instance name and click on properties. Here we can see we have different options. In the general tab, we can see the name of the product, the name of the instance is demo. Then we have the product information, operating system, and the platform, then version. So we have this 15.0.2000.5. So 15 means 2019. The language is English. The memory, total memory we have as 12 GB. And this 4 is a CPU core. This is the root directory where the SQL Server is installed. And this is the collision we have already talked about. Is cluster. If your instance is part of cluster, this value will be true. Here is XTP. It means extreme transaction processing or in-memory OLTP. So it is supported, it is true. And HADR means high availability disaster recovery. So this is not enabled. We have not, by default, it is not enabled. The next one is the memory options. Here we have minimum server memory and max server memory. So whatever value you will define here, for example, 1024, then SQL Server will take minimum of that memory when this instance start. And the maximum server memory is the maximum server memory that SQL Server may take. So ideally we or normally we keep it as 80% or 75% of the memory as per the SQL, as per the Windows memory. So for example, if you have the 12 GB memory in total in the Windows box, and if you have only one SQL instance, so I think 9%, so 9 GB or 8 GB, it is enough for the SQL Server, and rest 20% we can leave for the non-SQL Server applications in the Windows OS. Right. The next option is index creation memory, and this is in KB. So 0 means dynamic memory. Right. So in SQL Server index creation memory, it is just an advanced configuration. So that basically control the amount of memory we allocate for the sort operations. So whenever we are rebuilding the indexes or when we are creating the indexes, so all the sort operation, what memory it will take, it is set by this. If it is set as 0, it means the memory will be dynamic and SQL Server will decide on runtime how much memory it need to give. Other one is the minimum memory per query. So this is the setting which will again define the minimum amount of memory that SQL Server must allocate to a query before it can start the execution. Next one is the processors. So here it has selected automatically set processor affinity mask for all processor, and similarly for set IO affinity mask for all processors. So here, what is the processor affinity? So basically, this processor affinity determine which specific CPU cores SQL Server is allowed to use. And if we have clicked on all, or if we have clicked check mark, it will use all the processor available, right? Similarly, we have the IO affinity. So this binds disk IO operations like lazy writer and log writer to specific CPUs. Next, we have the security setting. So here we have Windows authentication and SQL Server and Windows. So this is called the mixed mode authentication. We have already talked about them. Then we have login auditing. So if we click on none, so nothing will be audited. And if we have clicked on failed login only, so if there is any failed login which is trying to connect to SQL Server, that will be recorded in the logs. And similarly, we have successful logins only, so we can record successful only. And if we want to record both, we can do both. So, but normally it will be failed login only because this will be used for the troubleshooting. Next is the uh, SQL Server or server proxy account. So what is this server proxy account? So it will basically control the security context for XP_CMD shell stored procedure. So when a user is running XP CMD shell using the sysadmin, the command execute using the permission of SQL Server service account. And if any person who does not have the admin rights, and if he tries to run this command, SQL Server will require a proxy account to ensure that those commands don't run with high level permission of the service itself. About the server proxy account. Uh, Next is the enable common criteria compliance. So what does it mean? So enable common criteria compliance. So as its name suggests, it is a compliance requirement. So if you are working with a government project or any very sensitive information like military or something, then you can enable it. And the next one is the enable C2 auditing tracing. So here C2 audit mode, it is an old version of the common criteria. It logs almost every action to the file. So in this case, if you have clicked this and if the audit log disk full, then SQL Server will automatically shut down. So please beware when you are selecting this one. The last one is a cross database ownership chaining. So, cross database ownership chaining is a SQL Server concept. In this, it allows a user to access the objects like tables or stored procedure in different database without being explicitly granted permission in that particular database. So next we will go to the connections. So in the connections tab, you can manage how SQL Server handles incoming and outgoing connections. So here we have maximum number of concurrent connections. So 0 means unlimited. We can set, if you set that to some limit, then you can limit those number of users. For example, if you set it 100, so if 100 first connection will come or 101 connection will come, it will deny the connection will fail. So this use query governor to prevent long running queries. If you click this and if you set any number, for example, 300 second. So if there is any query and where the estimated plan says that this will run for more than 300 seconds. So in this case, SQL Server will not even start the SQL Server query, right? And here we have allowed remote connections to this user. Remote query timeout. It is 600. You can set if you want to allow the remote connections, and this will be the timeout while connecting to the SQL Server. And next we have the database setting. So here we have default index fill factor. It is 0. So this will tell that how much empty space is left on each data page when an index is created or rebuilt. So if it is 0, which is same as 100, this means the pages are filled 100% with the data. Okay, and if you want to change it, you can also change it as per your requirement. Then we have default backup media retention in days. So here it is set 0. If you set is like 7 days or whatever days you set, that backups which you will take in this instance in this location, those will be present in that location for that particular number of days, and then it will be deleted by default. Then we have a compress backup. So by choosing this option, we can compress the backup size. And this is a resource intensive process. So whenever you are choosing this during the backup, it will take more CPU and resources. Then next is the compress backup. So the next is the backup checksum. So if you enable this, SQL Server will verify the data integrity of the backup as it is being written. This is the best practice to ensure your backup aren't corrupted. Then we have recovery interval. So this will define the maximum amount of time SQL Server should take to recover a database after a crash or restart, right? So here 0 means SQL Server manages the checkpoints automatically to ensure the recovery usually take less than 1 minute. Okay, now we have data log and backup. So this is about the location of those data log and backup files. Then we have the advanced option. So here we have multiple options. So you can choose these options as per your need. Here we will not look for all the advanced option, but as per your need, you can check that. So most important things are cost threshold for parallelism and the maximum degree of parallelism. So I have already explained you what is maxstop. So this cost threshold for parallelism. So it defines how expensive a query must be in terms of estimated CPU and IO before the SQL Server is allowed to use the multiple cores. So by default, this value was set to 5. I have set it to 50. So if you set it 5, so this 5 was a default setting since long in earlier versions. But this 5 is now every query maybe having this particular estimated CPU and IO. So if you click on 5 every, if you set it 5, every SQL Server query will use the max drop. So better to keep it 50 so that so that relatively higher CPU and IO query will use the max drop setting. Next is block process threshold. So default is 0, it means it is disabled, and if you set it to 10, SQL Server will generate a report every time a process is blocked for more than 10 seconds. So it may be useful for the troubleshooting purposes. So this is about the advanced option, and we have permission. So whatever account we have here, you can give grant with grant and deny permission. Here you can check whatever permissions are available, and you can do it or you can set it accordingly. So this is how we do the post install configuration. And here comes the most important part, that is the interview questions. So first question is, why is it not recommended to enable the SA account? So if you are a DBA, sometimes you may have noticed that in the environment, the SA account is disabled. As we know that SA account is a system admin account that has full and unrestricted access to the SQL Server instance. And as it is a well-known username, attacker always try to attack on this user account. And if this assay is compromised, your entire SQL Server is compromised. It can be data theft, it can be deletion of data, it can be a ransomware risk. And no one has the accountability because multiple people use your assay account. So whoever performed what action, you never know about that, because the same username and password multiple people may have, because it's a assay and common account. So the best practice also is that we should give the account a least privilege. But here, this SA account, it is widely known and it has the most privilege. So it violates the least privilege principle. So best practice is always use the named account and assign only the required permission. The next is, why is it a risk to leave maximum server memory or max server memory at its default value? So the default value for max server memory is the maximum. So in numbers, it is 2147,483,647 MB. It means whatever memory that particular Windows box has, it can take up all the memory. So virtually all the memory is available for the SQL Server instance. So if you set this, and if you have other applications in the SQL Server, then you can have the memory starvation for the operating system and other processes. It can also unstable your system and the system can crash as well. And if you don't set the limit, troubleshooting becomes very difficult because the memory usage can fluctuate widely, making it difficult to predict or control the behavior during the peak hours. So this is the reason we never leave max memory as the default one. The last, the next question is, explain how SQL Server browser service impacts connectivity for named instances. In what scenario would you disable it? So the SQL Server browser service is very important for connections to the named instances of SQL Server, particularly when those instances use a dynamic port allocation. First, let me show you something here. So I have three instances in my SQL Server or in my box. First is the default instance. If I go in the network protocol and Microsoft SQL Server or MS SQL Server, right click and properties. Here I can see the IP address, and here we see the default port is 1433, that is assigned to the default instance. But if you go to the named instance, you can't see that particular port. Right here, it is blank. What does it mean? Here, SQL Server is assigning a dynamic port to those instances. Those are the default, those are the named instances, right? Here, the port is not mentioned. We can mention the port if we want to make it a static, but by default, those ports are dynamic. So the browser service listens on UDP port number 1434 and it resolve the port number. So when a client attempts to connect to a named instance without specifying a port, it will first go and query the browser service, and it will retrieve the current TCP port number or maybe a name type information for that particular instance, and this will allow the connectivity with multiple instances on the same server, right? And if browser service is not running, connectivity to the named instance becomes very restricted. Clients can connect it, but only if they explicitly provide the correct port number. So you must have seen sometimes if you are connecting to SQL Server, in the connection string itself, you give some port number, right? One, but any random port you can give. So this is how you connect to the dynamic ports. So we can disable the browser service when we have a single instance in a SQL Server, or when we have a static port assigned to SQL instances. But remember, if you assigned a static port, then in that case, client should use the port number in the connection string. In that case, you can disable the browser service, and sometimes you can also disable it as a great security measures, because everyone know that the browser service listen on UTP port 1434, and it becomes an easy target for the attackers. So these cases, we can keep our SQL Server browser service disabled. The next is what is maxstop and how does it affect the performance. When would you set it to 1 versus leaving it at the default value 0? So as we have already seen, the maxstop is the maximum degree of parallelism, and it is a server level configuration option, and that determines the maximum number of processes or cores that a query can use while executing. Right? When a query is running with the large joins, aggregations, or scans, then SQL Server can split the work across multiple threads and each running on a separate processor to potentially complete the task faster. So for CPU intensive long running queries in data warehousing scenarios, splitting work across multiple processors can significantly reduce the execution time by processing data in parallel. So if you are keeping it 0, it means you are allowing all the available cores to use by the query. And if you are keeping it 1, it means you are allowing only one core per query. It means it is simply as disabling the max stop. Next is using SP configure. How would you enable and set the advanced options like cost threshold for parallelism or optimize for ad hoc workloads? Let me show you in a SSMS. So by default, if you run the sp underscore configure in a system, very less options. But if you enable this show advanced option, you will see all the options. So now if I run sp underscore configure, I can see multiple options. It has all the server level settings, which you can see here. So now if I want to set the cost threshold for parallelism as 50, I can run this command exec sp underscore configure cost threshold for parallelism as 50. First, let's see what is the current value. So here we can see the run value as 5. Okay, let me set it to 50, and then I will run this sp underscore configure again. So here you can see the run value as 50. So this is how we change the value of this sp configure parameter. So this is it for today. I know this is a long video, but I hope you have got enough information from this video. And please like, subscribe, and share this video. And if you really like the video, please comment on it, and I will see you in the next video. Till then, take care. Bye bye.